share 802.3, which is the Ethernet standard. Some of you may be familiar with Ethernet. So that's one of the standards that IEEE issues. And I want to share my 2 decades of working in the industry and the importance of standards, and give you some insight into the importance of standards. IEEE rules, they have rules. I have to say that I'm not speaking for the IEEE. Okay. I'm speaking for myself. So agenda. I just want to, just to briefly summarize, I want to talk about the fundamental nature of standards, the role industry plays in standards, which is very key, the value that standards generates, and there's also this value that industry invests in standards as well. And finally, I just want to touch on the changing landscape. Many of us are familiar with ISO, IEC, but IEEE is here, and there's also lots of consortia as well. And the relationships are becoming much more complex between all these different organizations. And then just go and give you an overview of some of the IEEE standards activities. Of course, what is a standard? And there are many definitions, and there's many shades of gray between formal standards and de facto standards. So the formal standards, which is very much what IEEE is involved in, are developed through some sort of open process, consensus-based, with some level of balance in there, the balance of the different interests. And then it establishes some form of uniform technical specification. A prime example of that we do within IEEE is 802.11, which is the foundation for the Wi-Fi technology you'll be familiar with, I've no doubt. In contrast to that, at the other extreme, there's the de facto standards. They tend to be internal corporate or product specifications that once they go into the marketplace are widely adopted and become a de facto standard. A classic example of that is the QWERTY keyboard that we're all familiar with. That started out as, it was engineered to stop keys sticking, was the history of it originally. But that layout was adopted more and more widely in typewriters, and then of course as the computing industry came along as well, the QWERTY keyboard was adopted there as well. Because that's an example of a regional, if you wish. It's certainly not an international de facto standard because the layout changes by country as well. So you have the QWERTZ or QWERTZ layout in Central Europe, for example. So it's not necessarily an international de facto standard, but that's a good example of a de facto standard. So standards improve quality of life. I mean, the key examples that I will use are, for example, we have in IEEE the 11073 set of standards, which are health informatics. So they're how information is exchanged between devices monitoring patients and central systems. We also have, shown here, for example, the green technologies. Electric vehicles are one, but another set of standards we do are called EPEAT, which are the Environmental Protection Assessment Standards, and they allow you to measure, for example, with computer monitors, looking at the whole life cycle and the way the products are manufactured as well as disposed to be able to rate them environmentally. Now, standards are pervasive. No matter where you go in the world, you'd be hard-pressed not to find some sort of influence from standards. There are national standards. I've mentioned international. There's also national standards. A prime example of a national standard is the power socket. Now, as you move from, it's not a common standard globally, so when you move from one country to another, it varies. But even within the particular countries, it's in large part because there is at least one standard for these, that you can have all these different electrical products. Imagine if you had different sockets as well as in just one country, you wouldn't be able to, you wouldn't find all these different devices that could plug in. There are global standards. One example shown on the other side there is the design automation. So the design automation standards like Verilog, VHDL, again, they're IEEE standards done by the Design Automation Society. As a matter of fact, it's the sponsor there. And these design automation standards have provided a great leap forward in our ability to define complex electronic systems. And of course, another example I will use is IEEE Ethernet and the wireless LAN standards. And they allow the internet to work seamlessly from region to region. We move around the world with laptops these days, and we just expect Wi-Fi to work. Now, this is the picture here I use as an example is from a village in Nepal. The reason I use this is when Vic Hayes, who was known as the father of Wi-Fi by many, he chaired the 802.11 committee for many, many years. When he won the Steinmetz Award, one of the letters he had was from the Dalai Lama thanking them for helping with Wi-Fi because they use it to communicate between remote villages. So it's very important that how pervasive these standards have become. So standards also grow markets. There's a lot of innovation that goes into standards. Although one thing I will say is that many think that the standards give you, when we issue a standard, it is the most up-to-date technology. It's not. It's a balance between technology and cost. You could have this wonderful forming technology, but it would be so costly that nobody could use it. So that's part of the standards process, is the balance between technology, economics, and the other one that comes in there is politics as well, and the global scale, which I'll cover in a later slide. We also have standards that protect health and public safety, and we've been doing this for centuries. The successor organization, the AIEE of the IEEE successor organization, developed a standard for self-inductance back in the 1890s. And in the 1910s, when the American National Standards Institute, ANSI, was founded, the AIEE was a founding member of that. So this has been going on for many, many years. This isn't something that's particularly recent. But here's a great quote from a former CEO of Intel. And standards contribute to innovation, interoperability, they help build business, they give consumers choice, and they increase the pace of technical evolution. They benefit the user and perhaps most importantly, industry. Standards diminish the barriers of international boundaries. I mean, this is very key that with what we do. The IEEE standards we do in the 802 arena, Ethernet, Wi-Fi, are global standards. So not only does it allow us as users, consumers, to be able to take our equipment around the world, you can plug into an Ethernet port around the world and it'll work. It also allows industry to manufacture one product they can ship around the world. And a little aside, with power over Ethernet, that is the one connector throughout the world. If you have power over Ethernet, you will get power from. So that's the one power standard I always claim, power socket standard that exists, is power over Ethernet. Unfortunately, doesn't give you too much power, so it's not the most useful for powering things. But it is the one connector throughout the world that will provide you power if there's power over Ethernet behind it. So how are standards used by industry? Here's an example. I have to confess, it's an HP product. It's a switching product. It's one of the Ethernet switches division I work in produces. But what I'm wanting to do here is illustrate how many standards that we quote in the data sheet for this particular product. And you'll see there's something in the region of 100 networking standards here. And this is networking standards as well. This isn't all the other standards that are involved, for example, EMC for power, for safety as well. So there are many, many standards, and they're very, very important for producing products for industry. Now, as I say, they're integral to industry, and industry invests heavily in it. They invest money, they invest personnel. And when you look at when I was at an 802.3 meeting last week, had about 250 attendees for about 4 days. When you look at the costs just in the people's time for those that were attending there, industry's making a huge investment in those standards. And one of the interesting things I always find with standards is industry, and all the stakeholders for that matter, send participants there. They contribute their intellectual property because they give us text that's their copyrighted text that we put in the standard. We then publish the standard, and what do? We charge industry to buy their standard from us. So in some respects, we're taking, I mean, what other industry, apart from standards, do you take some intellectual property and sell it back to the owner? Now, it's one way of looking at it. Now, of course, we have to sell standards to be able to pay for the processes that go on. What we do actually in 802 is industry actually supports making 802 standards available free, but generally standards have to be purchased. So this is a little study we did to illustrate how much industry invests in the 802 standards. I think it's actually 802.11, I think this was. And how much the IEEE invests. So when we look at, we do 6 meetings a year, 200-300 participants. They happen throughout the world. And then there's all the time that goes in behind the scenes with people working on developing those standards. This is, $1 billion is the estimate that was made for that. And when you look at that and compare it with how much the IEEE itself invests, it's very small. Now, in no way do I mean to denigrate the great work that the staff do back in Piscataway for us. We wouldn't be able to do the standards process without them. There's all the balloting and all the administration that goes on. It's a huge amount of work. We couldn't do it without them. But when you look at the comparison, the investment that's made there compared to what industry puts in there. And it's that small part there that is why standards have to be sold. We do need to find some way of financing that. Now, standards are important to the end user. They allow the end user to know they won't be locked into purchasing future products from a single vendor. The classic example I'll use is a Wi-Fi access point, or a Wi-Fi access point that's part of a DSL modem. If you buy that access point and there's some fault with it, you don't like it, you don't like that particular brand, you know you can buy somebody else's same wireless access point, and it will work. It will work. The Ethernet connection on the back to the DSL modem will work with that existing DSL modem. The wireless access point will work with all the devices you have in the house still that are Wi-Fi, your PCs, your laptops. And the reason for that is the open standard. So that's a very key component of what standards offer, is you give the customer choice and value and you avoid vendor lock-in. And that's a very powerful argument as well for a lot of companies when they go in to sell products, is that we support open standards. So that if you don't like the service, you don't like our products, we're not locking you in. And that assurance can actually help get the customer to buy your products, that you know, when you know that you support open standards. So there's various standards development organizations out there. Process developing technical standards, as opposed to de facto standards, generally operates under the umbrella of some sort of standards development organization or some sort of consortium. There has to be some legal framework. Because one of the biggest challenges we have in standards development is you have competitor companies coming together to talk about developing technology specifications. In particular, we talk about the cost. And we have to be very careful when we're having those conversations, because you can end up in competition issues, antitrust as it's called in the US, if it's perceived that we're talking about price and price fixing. So we have to be very careful that we need an umbrella, we need a set of rules under which we have those discussions. And for example, within IEEE, it's always, the rule is you can discuss cost, input costs. You can't discuss price. So you can't even hint at price. So basically, you don't have a dollar discussion. You can say how many gates it's going to take, for example, to build something, but you can't say it's going to cost $5. So we can have a comparison. This solution is going to take 10,000 gates. This is going to take 15,000 gates. But you can't say $10, $15. But as I said, standards development generally takes place under the umbrella of a standards development organization. So SDOs, such as the IEEE, have a set of, an ISO and IEC as well, for that matter, a set of time-tested rules for how we do standards development, how we define consensus, what the governance model is, methodologies. And that's what helps. I mean, really what it gives you is a framework under which the stakeholders can come together and develop the consensus and develop the actual standard. Now, in the past, there was a much more hierarchical organization within the standards development organizations, but it's changing more and more. The success of the IEEE standards is part of that. And for example, now the IEEE has a partner standards development organization relationship with ISO. So we actually jointly develop standards with ISO, we jointly develop standards with IEC. And that's part of the changing landscape. And consortium are also coming in and doing many specifications. The USB connector on your PC is a consortium that develops that particular specification. So just to use some examples of the influence that standards have had, and this is a random one, it's kind of not to do with our field of engineering, but I think it's a very good example of it. So, shipping containers. We're all familiar with them. We see them on lorries, trains, ships. However, the entire operation is dependent on all these containers being the same size or of fixed size, and also the fittings that help them stack together being standardized, being the same. So the containers today we see were first designed and patented as well by a trucking entrepreneur, Keith McLean. Before that, all non-bulk loads had to be shipped to a dock and then manhandled onto a ship and then shipped somewhere and then taken off the ship. Very time-consuming, and also, as well as being labor-intensive, time-consuming, there was also damage very often. So the container removed all these intermediate steps. Part of what I like of this story was the engineer, not the entrepreneur. The engineer realized that if you made this an open, at the time, de facto standard by releasing the patents, or at least licensing the patents on a reasonable rate, everybody would adopt this. Because if you just kept this technology proprietary and patent and used your patents to protect anybody else using it, then people weren't going to adopt it. So the engineer here persuaded the entrepreneur to make the technology available widely. And that led to the wider and wider adoption of that. So formal standardization through ISO took place in the late 60s, early 70s. And since then, there's been a massive growth and hence increase in efficiency. Something like 90% of non-bulk cargo loads are now transported by containers. And if it wasn't for that standardization, that wouldn't have been achieved. Something more familiar to us is Wi-Fi. These are numbers, actually slightly old numbers now, from a workshop we did in 2011. On the number of hotspots, the number of countries, 87% of hotels offering it. I saw a great cartoon, which was like kind of the attitude I think we're getting towards Wi-Fi now, which was somebody's being told, go and colonize Mars. You need to find water, you need to find food, and you need Wi-Fi. You know, those are the three things for humanity to exist these days. Now, it's probably as the Ethernet chair, I would argue it's internet and networking rather than just Wi-Fi. But that's sort of the attitude that is coming to these days, that it's just so pervasive and everybody expects it. Here's some numbers we were looking at. It's something like 1 million units a day of Wi-Fi connectivity that's being shipped towards the end of 2010, and they were heading towards 2 million units a day, moving on from that. And again, it's the open standard that achieves all this. And another key to this is innovation built upon open standards. Some think standards aren't innovative, but you need innovation to meet the standard, you need innovation to use the standard. And it's not Wi-Fi itself, it's just giving you networking. Why is there such a massive growth? It's because of all the innovation, that innovative products people are building, because now you've got this connectivity. So this is how open standards enable innovation. I've touched on standards quite a bit, but I'm sure you all are familiar with the Wi-Fi logo and the Wi-Fi certified. They aren't actually a standards development organization. So the 802.11 standard defines the wireless local area network itself. But the 802.11 standards group, the IEEE group, it doesn't cover product certification and marketing. So certification is where a particular organization takes a product and looks at the standard that product is claimed to meet, does some testing, certification testing, and then issues the certification. That is what you have to do to be able to put the Wi-Fi logo on your product. You have to be a member of the Wi-Fi organization, and as part of that gives you a license to be able to use the logo once you do the testing. Oops, sorry. Another part of what the Wi-Fi Alliance does, however, and these alliances, these marketing alliances that we have around some of our standards, is joint marketing. So again, it's a bit like I was talking about when we do standards development. We need an umbrella under which competitor companies can come together and develop standards. What alliances like the Wi-Fi Alliance does, and there's an Ethernet Alliance as well, What that allows is companies to come together and do joint marketing, joint promotion, particularly when there's a new standard coming out, 11N, or some of the new activities in Ethernet. So the alliances sort of complement what happens in the formal standards development organizations. But again, this is my message about innovation. Like I say, often people think standards are dusty, non-innovative. But how to build the standard, you can see a lot of innovation for that. Because the standard doesn't define how you build something. What the standard, the Ethernet standard, for example, will define is what the electrical signals on the connector should look like, what the frame format should be. It doesn't say how you should drive that. So whatever technology you want to put behind there, so long as you meet the specification of that connector, it's going to work, you're going to be conformant, you're going to meet the open standard. But you can be as innovative as you want behind that. But more key to me, the innovation I see, is the innovation on what you do, because now that you can move the information around. All these different products we see that are supported by Wi-Fi, by Ethernet, and everything becoming connected. And here's a great quote from Vint Cerf, one of the TCP/IP co-developers, saying that by allowing for the establishment of the infrastructure that leads to enormous entrepreneurialism, creativity, and competitiveness. So let's move on to just looking at what we do within IEEE standards themselves. So as I say, I've described it, the SDOs such as the IEEE really provide this umbrella under which stakeholders can come together to develop standards. And that's what the IEEE SA does. The Standards Association is one of the major business units within the IEEE. And we serve as a partner for the stakeholders to come together, to collaborate and develop their standards. And what we do is we maintain a process that helps to build consensus, and we do it through a global community of industry. Our standards development, certainly within 802, you will see global industry participating. So there are many areas that IEEE does standards. We do the National Electrical Safety Code, which is used in something like 49 US states, but also in over 100 countries worldwide. So what the National Electrical Safety Code is all to do with electrical safety up to the consumer unit. That's what that defines. The nuclear safety standards are also developed within IEEE, and again adopted as well. And the color books, again, industrial commercial power systems, another set of standards that IEEE does. And the medical devices, the 11073 ones, which I was mentioning earlier on, that's another set of standards. But those are actually developed co-developed with ISO-IC, as a matter of fact. But those standards allow you medical devices, to communicate with central systems. And standards that define the future. So how many knew that 802.11, originally Wi-Fi, was originally pushed by NCR because they wanted to do cash registers, wireless cash registers. So that's actually that's what started the whole idea of 802.11, which eventually became Wi-Fi. So we work on the standards that define the future. 802.11, as I say, was originally conceived for just in connecting wireless cash registers, but is evolved into something that benefits society. And we see revolutionary new devices we couldn't have imagined a decade ago, your iPad and all this, that all support Wi-Fi. So looking at the internet itself, when you look at the set of standards that define that, and interestingly enough, none of them come from the big I's, the ISO-IC, the ITU, the IAC. None of them, these standards which really define the whole internet, come from those organizations. So IEEE, we do the networking. So we do the Ethernets, the Wi-Fis, the WiMAX. Bluetooth is actually an IEEE standard as well. So we do that foundation. Built on that is the IETF standards, which do all the routing protocols. And then you move on to the W3C, which do the browser specifications, the browser standards. And finally, we have OASIS, which does there's applications. And really, I mean, this is I keep doing that. This really is redefine the information. paradigm. There's no borders. No matter where you are in the world, connecting a device onto the internet is simple and it's universal. But the key, why do people come to IEEE? Why have we been successful? And part of it is this, we have a rigorous standards process. And I promise this is the only slide on standards process. I could do a whole hour on it, but we won't. And the fact that we have a very widely respected, in fact, the IEEE brand itself being so highly regarded as a singularly trustworthy source of high-quality technical standards is very key, and that brings people back to it. But I do think, I mean, I really do think we have a very good process, and I'll come on to some of the dynamics, and it's that balance between the dynamics that's very important between, again, economics, technology, and politics, and it's finding the right balance between them all. We define consensus. We define consensus as meaning 75% or greater. Any technical decision we make in the standards process has to get to 75%. And that's good, because you don't end up, if you only get to 50%, you can have things flip-flopping. Having to get to the point of 75% of those participating, agreeing with the approach we're using, means once you've got to that point, it tends to stay. We have due process, that's really involves us making sure we have a set of rules, they're published, everybody can find them. So everybody plays on a level playing field. Openness. 802, for example, 802.3 meetings. We have, the rule in those meetings is anybody in the room who feels qualified to vote can vote. So if you can come to our meeting and you walk in and you think you're qualified to vote on it, you can do so. That's the process we use for developing the initial draft. It then goes through more formal balloting processes. Towards the end, we do a sponsor ballot. There's a public review again. Anybody can vote on that. If you're an IEEE member and you can join the SA, you can ballot on as many of those as you want. It's included the membership. If you're not a member, you can pay a one-off balloting fee. But it's an open process. Anybody can be involved in that balloting. So some statistics, we've got something like 1,100 active standards, more than 500 standards under development. We have something like 7,000 individual members. So these are the IEEE SA members. While we have 7,000 individual members, we have about 14,000 people participating. Because remember, I said you just need to be in the room. You don't have to be an IEEE member. You don't have to be an IEEE SA member to be able to participate in our process. And many, probably about half of those that participate aren't actually members. It's an open process. We actually have two systems within the Standards Association. We have individual membership, where it's one person, one vote. That is what the process under which the 802 standards are developed. But we also have what's called an entity process, which is more familiar in many other organizations, where it's one company, one vote, although it's more broader, it's one entity. A university, for example, can be a member as well as a company. In that particular case, we're like the first part of the IEEE that actually has this corporate or entity membership model as well. But what's happening today when you look at the standards arena? Things are changing. Say markets are becoming global, but they're evolving. And there's even more pressure for us to develop things quickly. And we have a lot of we're challenged by the various consortia that are set up to do standards development. I said USB was an example of where, rather than going to a formal organization, they set up their own consortia and went and developed the standard themselves. So as a result of that, we have to, within the IEEE, we have to offer industry a variety of choices to allow them to develop collaborative documents. So not just the standards, the more classical, if you wish, standards development process that's been used over the years. So one of the areas that we offer in this is something called industry connections. It's, as I say, it's a less formal development process for consensus documents. We're actually using that within 802.3 Ethernet at the moment to develop a bandwidth assessment. So what we're doing there is inviting industry to come in, tell us what their needs are moving forward as far as bandwidth is concerned. Do we need to do 400 gigabit per second as the next speed, or do we do 1 terabit? There's a lot of debate in the industry about that, but really we need to go to the end users and find out from the end users what their needs are and based on that, we should go and develop the next standard. So that's the approach we're using there. But it's a less formal. We're not going to develop, at the end of that project, we're not going to develop a standard. We're going to develop a report that says what the predicted bandwidth needs are, bandwidth usage moving forward is. And only based on that report would we then consider doing a standard. So this is part of our, addressing the needs for a more faster and time to, to address the ever-shortening time to market cycle we see. But the dynamics in our standards development meetings are complex. I keep saying this: technology, economics, politics. Those are the three things that drive standards development. Personally, the more technology, with some economics, and no politics, in my opinion, is the best way to do it. That isn't always what happens. Certainly within IEEE, because of our technology focus, I believe we do that. And that's actually what I would argue is our success. For example, in 802, is we very much, technology and economics are the two we focus on. There's some politics. And when I'm talking about politics, it's global politics, particularly with some of the emerging nations and their desire for a seat at the table. And people are still learning how to participate and learning how to interact with the standards process. Back to our balance between technology and economics. We could do a purely technology-focused standard, use the absolute best technology, but it would be a science project that really industry wouldn't be able to use. It wouldn't be cost-effective. So we need to take this balance of looking at the economics of the solution as well. And that's a very key part of the standards process and the standards development that we use in 802 and IEEE. So we have international, I've talked a number of times that the 802 standards are globally adopted, so are many other IEEE standards are globally adopted. And we certainly have participation and presence throughout the world. To just show some of the locations we have. Just moving into more detail, we have the global offices. The IEEE has a number of offices, and we leverage those as well for a lot of the standards activities. So we just recently we've opened an office in Brussels, and there's a standards component to a number of the activities there. We have the one in India, China, particularly in the area of standards education, which is something I'll touch on at the very end. We have a lot of activities in China and India. Of course, the SA headquarter in Piscataway. We also have memorandums of understanding. These are between the Standards Association and various national and the international SDOs. They can vary. Sometimes they're as simple as a particular national standards development organization wants to adopt one of our standards. So that's all the agreement is about. Or it can be much broader. For example, as I mentioned with ISO, we have a partner standards development organization agreement, MOU, where we can jointly develop standards in the area of information technology. And also it can be just broader, where it's a cooperation agreement, where we may do workshops and other activities with them. So there's always this, it's not one size fits all. We try and work with what the particular organization is interested in doing with us. Events, we have events, meetings, workshops around the world. 802.3, for example, this year is going to be meeting in Geneva in September. Anybody's welcome to come there if you want. There's actually a workshop on the weekend before the meeting, and then we're meeting for the entire week there. There's no meeting fee because it's being held at the ITU headquarter building. They're hosting us there. If you can get there, you can participate. Or if you're interested in the workshop, you can come and listen to that. The workshop's going to be looking at what the future direction we have back to this 400 gigabit, 1 terabit discussion that's going on. That's one of the key things we'll be talking about there. So just drilling down into a bit more detail of some of the activities we have. Say we've got MOUs in various parts of the world. There's going to be a standards meeting in the Czech Republic later on. We did a standards workshop at EnergyCon, which is part of Region 8. There's a lot of activities we actually do with the Standards Association with Region 8. They're a great partner of ours in that area. Now, as I said, the big eyes, if you wish, the global standards development organizations, which, by the way, I will say the IEEE is another global standards development organization. Are ISO, the ITU, and IEC. And these are the ones, as I say, we've got development agreements with. We'll actually do joint standards developments. So, for example, 802.11, Wi-Fi, is actually published as well by ISO under the designation ISO IEC 8802-11. So that's just simply an adoption of what we do within 802.11. That's one example of it. A lot of the power engineering standards that are done, because in that particular case, some of the standards are more US focused, they'll be done in partnership with IEC. So we'll actually jointly develop a standard between ourselves and IEC in the power engineering area. So there's a lot of international collaboration that goes on. So this is the industry connections, as I was mentioning. This is the less formal standards development approach. It doesn't follow the more rigorous process that's been established. And what it does is the idea is to allow people that are thinking about maybe starting to do standards to come in and start developing some documents, some processes that maybe then will be taken to formal standards. One example of this area has been antivirus. So a lot of the companies that do antivirus products are getting the signatures of various viruses. And if somebody in one company knew somebody else in another company and trusted each other, they'd maybe share them. But there was no formal way to share all these viruses around the industry. And of course, the threat growth is growing exponentially all the time. So one of the activities under Industry Connection was for them to come in and look to see if there was some way of producing a standard, if you wish, or at least some central repository to share the virus information in some standardized form. So there's no formal standard being developed in that area yet, but it's an incubation effort to see if they would like to do that longer term. It's a much quicker and cost-effective process, and it allows us to develop other products, for the want of a better word, other than just standards. We can do white papers, peer review specification guides, position papers, and other information like that. So one of the areas that I mentioned, for example, was certification, and that's one of the areas at the moment that's outside the IEEE. But part of the IEEE, or the SA now, would like to be able to offer those extended services, the other value-add features, if you like, beyond standards development. Certification would be one example. Another key one that we do already is authoritative registers, or registries, should I say. So I'm sure we're all familiar with the MAC addresses, the Ethernet addresses, the MAC addresses you'll see on Wi-Fi devices or Bluetooth devices. Those numbers have to be globally unique. Fundamentally, that's how a device is identified, by a globally unique number that's burnt into the system somewhere. And therefore, you need a global registry that allocates those numbers. Otherwise, it won't work. If two devices end up with the same number, communications will fail. So that's one of the registries that the IEEE actually holds, is that registry. And it's very fundamental to the standards, and very, very, very fundamental to the way the internet operates. But other activities, conformity tests, marketing and education, and other areas. So really what we want to do is offer the whole life cycle from the incubation through the actual formal standards development and some of the support after that. So just some concluding thoughts. Worlds need standards. Key, and this is why industry commits to it as well, is to give consumer choice. If you can assure the consumer that we conform to open standards, you don't like our product, you can go and buy somebody else's if you don't like it. That's an amazingly powerful argument. And what that actually does is grow markets. Back to the shipping containers. If that had been kept proprietary and hadn't been made open to everybody, you wouldn't have had the growth in shipping containers. If every container was a different size, you wouldn't have had the efficiencies. Technology growth, again, what we've enabled by the open standards that provide the internet communications through the IEEE, the IETF, W3C. It's a huge explosion in technology. And of course, the interoperability, as I said, giving you the consumer confidence. And the other part of it is to have global standards now for the global markets we see in the world. They're a very fundamental tool to engineering. So, just a couple of slides on what the IEEE is specifically doing that might be of interest. We have something called the Standards Education Committee. It's a joint program between the Standards Association and the education activities. Where's Tariq? Tariq was a great supporter of this when he was the chair of the vice president of education activities. I should get that right. Of course, he's now running for, he's a president-elect, but anyway, running for that. Anyway, it's a joint committee, as I said, between the Standards Association and the EAB. And what we want to do is promote standards and the integration of standards into academia. And we want to do that by providing learning material and short courses. Because one of the problems I think we're observing, and the industry's observed to us, is that you'll go through the whole education system, you'll start your first job, and then you'll be given this stack of standards. Remember the product I was showing you, the Ethernet switch I was showing you, the 100 networking standards you have to conform to. And sometimes that's the first exposure some have to standards. So what do we want to do to help promote this? The first one is we actually have a program offering student application paper grants. This is a grant of $500 to the student, $300 to the faculty advisor for, if you have a final year project that somehow incorporates standards into that project, we will offer the grant. Now, if you're doing a robot and you're buying a Wi-Fi module to control it, you're not really getting into the standard. What we're looking for is where you're actually studying the standard, or maybe making a decision between different types of standards. Do I use Bluetooth or Wi-Fi, and look at and analyze the standard and choose between them? So that's the sort of project we're looking for. And one of the other key things is the paper, if accepted, is published. So that's actually sometimes a very nice thing to be able to put, that you've had a paper published by the IEEE. Another thing we have is Try Standards. This is a search portal that we've just set up. A couple of things this does. You can go and search here for standards in the IEEE's area of interest, not just IEEE standards. If you put if you put Ethernet in there, it will give you the IEEE standards, but it will also give you the ISO IEC ones that are built on the Ethernet standard. The other part of this, which we're just building, and if anybody can help me with, please let me know, is courses that offer content about standards. There are 2 or 3 courses in the world, actually, that are purely about standardization, but they're, to some extent, are more related to economics and the economic impact of standardization. But what this portal is trying to do is list any courses at any universities worldwide that have content about standards in them. We have a standards education e-zine, and what this does is offers various content. We'll have video interviews with the IEEE SA president, Steve Mills, talking about the importance of standards. We also can also have peer-reviewed papers, also other content related. Well, I mean, the most recent edition is the Smart Grid. It's an edition about Smart Grid, and it has various articles about standardization within the Smart Grid area. And finally, online tutorials and case studies. There's a few here, excuse me, that you can access. These were actually developed with an NSF grant. One final thing I haven't mentioned here, but we have a Standards Education Speakers Bureau. What we can do with that is that we will provide speakers at events. So if you've got some local event and you'd like somebody to come and talk about standardization on a particular area, the Speakers Bureau will fund that person's travel. So if anybody's interested in that as well, let me know. That's an opportunity for local organizations to do. Finally, just some contact information. If anybody wishes to get hold of me or the program manager for standards education or the counterpart within the SA. So at this point, any questions?
Thank you very much.